Hi, welcome back to this third lecture on state machines. And here I'm going to go over the assignment question to help you gain an understanding of what's required of you. So let's have a look at the block diagram for this system. We've got a switch connected to some sort of door on a safe, and we've got the actual lock itself of the door. So let's see, what does the question look like in the assignment? Let's go to the assignment question. It is the electronic safe, question 53. So let's have a look at the block diagram. There it is, and the instructions. And the instructions will show, here's the safe. Fairly sort of typical hotel type safe. What happens is that you enter the 4-digit code in this case, and the door unlocks. Then you can open the door. Okay, so you need to just clarify in your mind exactly what this door sensor is doing. It's determining whether the door is open or closed. It is not controlling the door. It is not an output. It is an input. There is no output that swings the door open or pushes it closed. Okay, there is only a lock. So this determines whether the door is open or closed, and this here controls whether the lock is released or not. Okay, and of course you've got a keypad here, which every time you press a different number, it gives you a different analog to digital conversion voltage. Okay, we've got a star and we've got a hash and we've got these 4 letters as well. So let's just think about the operation of this system. When you enter the 4 correct digits, the system in here releases the door lock. And then if the door is unlocked, but it is still closed, in other words, you've entered the right key, but you haven't actually reached and opened the door of the safe, and you walk away, you don't want to leave it in that state where it's actually unlocked. So after 20 seconds, it must automatically lock again, okay, if you don't do anything. If you unlock the door and you open it, after 20 seconds, it will still automatically lock the door. And that just means that when you push it closed, it will be in a lock condition, okay? Then there's the ability, I think actually it says here A, but I might say H somewhere else. We're not going to go into actually how you would program a new code in this exercise. That's not required of you. It's the logic around operating the door lock, sensing whether the door is opened or closed, and of course checking to make sure that you've got the right 4 digits entered in the right order. Okay, so let's have a look at the actual state machine itself. Well, we've got a few functions that we can put into the state machine, which is to unlock and lock the door, read the keypad, which is really just get a value from the keypad, and then there's the state machine. So I'm not going to look at it in the notes here. We will come back and look at this question down here. We'll actually look at it in the assignment itself, okay? So let's have a look at the state machine here. What have we got? We've got a state machine, okay, and over here, let's see, our initial state is state locked. Let's just have a look to see what the initial state is. Down here, there must be an initial state somewhere. Here we go, here's all the state machine stuff. So you can see all the different states of they're all macros, simply just numbers, 1, 2, 3, 4, 5, 6, 7. If you added another state, you would get number 8. You don't need to add states. I don't want you to remove states. I just want you to look at the logic of the transitions between the states, okay? So at the moment, it starts in state locked, so it's in this state here, and all it does in state locked at the moment is get the key. So it reads the keypad. Get key is just simple, a function here. Here we go, read the keypad, and it does something based upon the keypad values, and the keypad values are already defined up here for you. Okay, so you don't have to worry about that. You've already done that in the previous question. Right, so if we're going down here, we're waiting for the first keypad value. So here we're waiting to see if it's code 1. So let's just make it nice and simple. The code is 1, 2, 3, and 4, okay? Now, what happens if you press 2? Well, keypad value does not, and you can see I've put a little few things in here for you to fix, like there's one of the things for you to fix there. So if keypad value doesn't equal code 1, then it will just stay here, okay? It will just continue to read the keypad until the keypad value, until the keypad value equals the correct code. Okay, so what I want you to do is I don't want you to edit any code over here. I want you to do your editing over here, because what I will do is when I mark this question is I will go through the things that I'm looking for here. I won't actually run the auto testing of this myself. I will look at this and think, have you got the right expressions in the right places? And I'll just give it a manual mark myself, okay? And I'll deduct marks for things which are incorrect. So let's just think about this, for instance, when the keypad is equivalent to 1, it goes into the state. So while it's in this state, it will again, we're in state 1 correct, it will read the keypad, and then there's a problem here, of course. It's going to transition because there's no condition here to transition. So you have to enter the transition here. What is the transition that will cause this to go from state 1 correct to state 2 correct? Okay, now if they are, now you've got to think about this, and this is where you've got to understand and realize the stuff about switch checking in a microcontroller, because things happen so fast. When you press the first digit, say it's 1, it comes into the state, but it is still going to read this value until well, it's going to read it forever. So if you hold this value down on your keypad number 1, immediately it's going to go into here, and it's still going to sense that 1 is pressed. And so you don't want it to go back to this error state or the beginning again, and you don't want it to go on, okay? So you wouldn't, for instance, program a system where you had the numbers 1, 1, 1, 1, 1, okay, because then it would just immediately go straight through these into the unlock state. So what you want to do is make sure that that no 2 digits are sequentially the same. So you don't have 1, 1, 2, 2. You could have 1, 2, 1, 2, but you couldn't have any 2 sequential digits the same. So that's the sort of testing and thinking about this. You don't have to go any more complex. I'm not asking you to make it work so that you could have sequential digits the same. What happens here is it will go back to the locked state and ignore your key press if it's not equal to 1, if it's not equal to 2, and it's not equal to unpressed. So you've just got to think about that logic there, okay? And it's understanding the logic of what's going on here. You'll notice that we are doing testing here with not with our Boolean identifiers and doing bit testing, but we're actually testing variables here. Okay, so that's why we're using a double ampersand for our testing to see if the values are true or false. Okay, so what we want to happen is when you press 1, we want it to stay in this state while the 1 is still pressed on your keypad, and then it will stay here until you press another digit. So we don't want it to go back here if it's a 1. So only go back here if it's not equal to 1. Now, if you press a 2, you want it to go here and not here. So this second line, keypad val doesn't equal code 2, is really important because this is what makes it deterministic. This makes it clear that it can only exit this path, down this path, if it's not a 1, if it's not a 2, and it is unpressed, okay? So if it's unpressed, then we don't want it to go down here. And you can look at these values and think about them. Here's the values, okay? Unpressed is going to give you a value of 50. So we don't want it to go down here when the value is 50. We don't want it to go down here when the value is 120, which is a 1. And we don't want it to go down here when the value is 142. But we want it to go down here if it's any of these other values. So that's what this line of code is saying. And we could, of course, put in a bigger test here to say that if it is 3, 4, 5, 6, 7, 8, 9, 0, S, H, A, B, C, D, then go down this line. But I've said go down this line if it's not one of these 3, but you could have said go down this line if it's one of those here. So that's the way of thinking about your logic, okay? And of course, you want it to go down here if it's equivalent to code 2. And then, of course, you've got to figure out what goes into these transitions and what goes into these conditions for these transitions here. Now, when you get the right number correct, you come down here to the unlocked code. And this is where you've got to start thinking about, well, what were the conditions? So if we go to our, if the door is not opened by the user, then lock must be called after 30 seconds. So in this unlock code, you must transition down here after 30 seconds. Now I've put a really simple delay for 1 second in here, and increase the count. So you can just think about what will cause this to go in a transition. And again, what would cause this to actually transition to the open state? So in other words, the door is open, it's been unlocked, and it's now open, okay? And then what would happen for this to transition back to the locked state? Now, down here is if you press the hash key to enter a new code, I don't want you to worry about this at all. Do not do anything about this. You do not need to add code here, okay? I'm just interested in these states here and these conditions for the transitions, okay? And of course, if there's any particular actions that need to take place and certain things that you need to put in. So you need to take some time to think about this. It'll take a little while to do, okay? So that really, let's just have a look at my notes to say, hey, does this code express every possible combination of the logic for exiting state 1 correctly? So this is the code for this transition out of here. Okay, so that's this code here. This is the state code for this. While state equals state 1 correct, get the key. If the keypad doesn't equal code 1 and doesn't equal keypad and code 2 and doesn't equal unpressed, then go to state locked. Otherwise, go to state 2 correct. And I've got here wait for unpressed. So I've put in an extra little function in here to say wait for the key to be released before it goes into the next state. So you could put that in if you want to, okay? So you'll see, let's go back to the code. I haven't actually implemented that, but you could implement it if you want to, okay? But that's a little, well, you can decide whether you want to put it in or not. This is up to you to do the design, and I'll just give you a good bunch of marks for doing it. So that sort of wraps up the lectures on state machines. There are several questions for you to do on them. As we look down this, you'll see where are we working down the bottom here. We've got the electronic safe 53. We've got an interrupt based one. We've got some traffic lights and timers. These state machine questions, you're not going to see the grades for these until after the assignment's closed and I've manually checked them, okay? So these ones here. Cool. So that's the end of the information on state machines. Actually, some very short lectures. I won't go on about this, but you've got some hard work to do on those assignment questions. Cheers.